Hello students, welcome to Educate. In the last video, we have discussed about physical properties of haloalkane as well as the chemical properties, and in the chemical properties, we have discussed what is electrophile and the nucleophile. Electrophile means electron seeking, and that will carry the positive charge or the electron deficient molecule. The ion carrying negative charge, that means anion, or the electron deficient molecule could act as electrophile. And in the same way, nucleophile or the nucleus seeking or nucleus loving will be those species which will attack towards the positive side, and those ions or the molecules, the ions or the molecules will act as nucleophile, in which there will be the negative charge or the atom contain lone pair of electron like this one. And a nucleophilic substitution reaction means the nucleophile will substitute the halogen. So now let's see, that was about this one. And now there will be nucleophilic substitution reaction. Okay, in that one I have not taught you about the ambident nucleophile and unident nucleophile. So first of all, let's see what is ambident nucleophile. Watch out here, when you consider about, here you have studied NH2, that is NH2 is nucleophile because here is lone pair of electron. So in this case, only nitrogen can donate their electron. Here NH2 act as nucleophile because nitrogen can donate their electron. Okay, and OH minus, that's also act as nucleophile because there is 3 lone pair of electron at oxygen, and oxygen can donate their electron. When you consider about the Cn minus, so in Cn minus there will be a lone pair of electron at nitrogen and a lone pair of electron at the carbon. So what is here in Cn minus? In Cn minus, the carbon can also donate their electron and the nitrogen can also donate their electron. So in this case, both two atoms can donate their electron. Then it will be called ambident nucleophile. In the same way, here in SCN minus, sulfur will also carry a negative charge, nitrogen also carry negative charge. So here sulfur can also donate the electron, nitrogen can also donate their electron. So in case of SCN minus, here sulfur valence electron 6, so 1 electron has been participated in bond formation, so 5, so 5 electron will be there and 1 extra one negative charge, that means 1 electron will be there. If any atom, if in the ions there will be positive charge, means that have the deficiency of 1 electron, and if there is negative charge, that means there is 1 electron extra. So SCN minus, this like this. So same here, in this case SCN minus also, the sulfur can also donate the electron, nitrogen can also donate the electron. So this one is also an example of ambident nucleophile. So these two, they are unident nucleophile. Unident nucleophile. Why unident nucleophile? Because of NH2, only nitrogen can donate the electron. In the same way, in OH minus, only oxygen can donate the electron. That means of this nucleophile, only one atom have the capacity to donate the electron. And so that's why it will be called unident nucleophile. But in these two example, the two atoms have the capacity to donate the electron. So that's why that will be called ambident nucleophile. As unident means only one donating site and ambident means from both sides electron can be donated. So unident nucleophile, only one electron donating site, and ambident nucleophile, there will be two electron donating site, two or more than two electron donating site. So that will be called ambident nucleophile. Okay. Now let's see here about that. The reaction, nucleophilic substitution reaction, takes place through two mechanisms. Mechanism, that means in which manner reaction is taking place. In chemical kinetics, listen by there. So that means in which step mechanism of reaction means how much has in which steps the reaction takes place. Here it will be clear. So the nucleophilic substitution reaction takes place through two mechanisms, that is SN1 mechanism and the SN2 mechanism. The nucleophilic substitution reaction takes place through two mechanisms, that is SN1 mechanism and SN2 mechanism. What is SN1 mechanism and SN2 mechanism? So when the rate of reaction will depend on the concentration of only one reactant, that is haloalkane. When the rate of reaction will depend on the concentration of haloalkane but not on the concentration of nucleophile, then it will be said that the nucleophilic substitution reaction takes place through SN1 mechanism. SN1 reaction mechanism, but that is when the rate of reaction will depend on the concentration of haloalkane only and not on the concentration of nucleophile. Then it will be said that the reaction takes place through SN1 mechanism. And the reaction in which the rate of reaction will depend on the concentration of haloalkane as well as on the concentration of nucleophile, then it will be said that the rate of reaction, then it will be said that the reaction takes place through SN2 mechanism. Okay. So now let's see SN2 here given here. What happened in SN2 mechanism? In this case, you have already know that the shape of this one will be tetrahedral. Let's watch about this molecule. Here Cl, hydrogen, hydrogen and OH, like this one. Hydrogen, 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 and this one is chlorine. So what happened during SN2 mechanism? The nucleophile approaches towards the alpha carbon atom. That means the carbon atom to which the functional group is attached. That is called alpha carbon. So nucleophile approaches towards the alpha carbon atom from the backward side of the halogen. The nucleophile approaches towards alpha carbon atom from backward side of the halogen. As a result, what happened? When the nucleophile approaches towards this side, then after there will be cleavage of carbon halogen bond and there will be rearrangement of these groups, atoms or groups bonded to the alpha carbon atom. So here what happened here? In this case, since there is in the reaction, there is involvement of the nucleophile as well as haloalkane also. So that's why the rate of reaction will depend on the concentration of haloalkane as well as on the concentration of nucleophile. In this reaction, there is involvement of nucleophile as well as the haloalkane. That's why the rate of reaction will depend on the concentration of haloalkane as well as on the concentration of nucleophile also. So that is in SN2 mechanism. So here never say in SN2 mechanism, what is that? So when the rate of reaction depend on the concentration of haloalkane as well as on the concentration of nucleophile, then it will be said that the reaction takes place through SN2 mechanism. And in SN2 mechanism, the nucleophile approach towards the alpha carbon atom here. This nucleophile approach towards this alpha carbon atom from the backward side of halogen. As a result, there will be formation of intermediate. And what happened? As the bonding between this nucleophile and the bonding between this nucleophile and this carbon atom strengthened. Through that extent, the bonding between this carbon and this halogen will weaken. That means there will be initiation of bond formation between the nucleophile and the carbon atom and the cleavage of carbon and halogen bond. So there will be a stage, intermediate stage, in which there will be a weak bonding between the carbon and the nucleophile and the carbon and the halogen. So that is intermediate here. And then after, finally, what happened? This bonding will dissociate. Firstly, this bond has weakened, and then after, this bond has been weakened, and then after, there will be complete dissociation of this bond. So Cl minus will separate out, and the nucleophile will be bonded to this carbon atom here. So finally, this product will happen. Okay, here when you, I think here anyone have not filled the everyone knows the meaning of solid phase and this dashed phase. But even though if who don't know that, listen here. Solid phase means towards the observer, and dashed phase means away from the observer. Let's see here. So at most, when the shape is here tetrahedral, shape is tetrahedral. Here CH3 of this molecule. So haloalkane here no double bond. So shape is tetrahedral. So at a plane there can be maximum two groups at two hydrogen or two groups only, and this carbon along with this carbon atom at a single plane there will be maximum two groups. So this group and this group, in this case suppose this is on the paper, so this group and this group is not on this plane, it is, so it is here away from towards the observer. This group is towards the observer and this group is away from the observer. So which is, that means when I kept here, when you kept below to your eyes, so what you will find out that this is red color pen, that is towards you, and that of this yellow orange color pen, that is away from you. So the solid wedge represents the bond or the groups which is towards the observer, and the dashed wedge represent the groups which is away from the observer. So that is here. So finally what will happen? So when the reaction will take place through SN2 mechanism, so bond has been formed from this side. Initially chlorine was to here towards the right hand side and nucleophile will be towards left hand side. So there will be rearrangement of this group also, and they will rotate through 180 degree. So there will be rearrangement in this group. In this group also there will be rearrangement, and rearrangement will be so that after that, that means after rearranging, there will be minimum repulsive force between this group, this group, this group, this group. There will be minimum repulsion. During the bond formation, that means whenever there will be covalent bond formation, then all the atoms will lie in three-dimensional space, so that the electron through which they are bonded will experience the least repulsive force. Okay, so when initially chlorine was this side, so this group was arrangement was this one. When this OH will bond from the opposite side, so there will be reversal of this group also. This one group also will reverse. So that means there will be inversion of this group also. That means configuration will inverse. So let's see, we will go through again stoichiometric coefficient, stoichiometric aspect on that. But right now, keep this one also in your mind. Okay, so when the reaction is taking place through SN2 mechanism, then the groups which were bonded to the alpha carbon atom, that will inverse also. Okay, now let's see another one. That was through the SN2 mechanism, and then after in SN1 mechanism, the reaction takes place in two steps. When the reaction will take place through SN1 mechanism, that will be in two steps. That will be here. Suppose here, this compound. This one has been taken. This is an example. What is actually here? Structure is that here this carbon atom and 3-methyl group is bonded here. And the nucleophile OH minus ion bonded. This reaction takes place in two steps. Whenever, just I tell you an example. I think you have seen in a number of movies that whenever there be exchange between the two negative role persons, like what will that is criminals, between when there be exchange of the goods between the two criminals. That means one is purchasing, another one is selling. Then they gives, from one hand they gives and from other hand they take. So during that course the exchange takes place simultaneously. So might be in the movie you have seen. Okay, so what is called in Hindi, that is called एक हाथ दो एक हाथ लो, एक हाथ से दो मुझे और एक हाथ से लो. That means in the movie also you have seen, that means from one hand they give money and from other hand they take the goods like drugs or gold or diamond, whatever be that. So and particularly to escape out from the vision of the customs. That is here. So through one hand they give, through other hand they take. And same another person, through one hand they take the money and from other hand they give the goods. So same here in case of nucleophilic substitution reaction. From one side there is bond formation and from other side there will be dissociation of bond. In case of, but in our day-to-day life, what we do? We take firstly the goods and then after pay the money. Or sometimes we also gives the advance to the shopkeeper and tell my money will be advanced with you, and whenever I will need your articles, then you provide me. Okay, so that is, in that case there is SN1 mechanism. So listen here, in when reaction takes place through SN1 mechanism, that takes place in two steps. First one will be cleavage of carbon halogen bond. Here is the structure. This carbon here, suppose this one. So in step 1, what happened? This bromine takes its own electron as well as the electron of this carbon atom also. So there will be a negative charge on this bromine because this bromine have taken one extra electron. That's why there will be a negative charge on the bromine. But for the carbon, there is loss of electron. So there is a loss of electron. So there will be development of a positive charge. So here, this methyl group, and this reaction is, there is cleavage of covalent bonding. There is cleavage of covalent bonding. So that will take place slowly. So this step will be slow step. This is slow step. Step 1. What happened in step 2? This carbocation and the nucleophile which will approach toward this carbocation. Nucleophile will bond there. So then after finally there will be formation of this nucleophile that may be either OH or any other nucleophile also. And this step is first step. In the chemical kinetics, the slow step is the rate determining step. Slow step is the rate determining step. Suppose what to take the example. So anywhere in our day-to-day life, you may experience also. That means process which will take place slowly. That is when you will get order. That will be depend on that. Suppose you are using kurta and pajama, the tunic and the pajama, kurta pajama. So what happened? Suppose the tailor, from the two different tailors you have given the order. The tailor to whom you have given is slow. That means the tailor who stitch your pajama slowly. So when you will wear and the pajama and kurta, because without pajama you will not wear the kurta pajama both. So the tailor who is stitching the kurta is fastly, and the tailor is stitching the pajama very slowly. So when you will wear the kurta pajama, that will depend on when the tailor will give you the pajama. So stitching of pajama was a slow step, and that's why the rate of reaction will depend on the slow step. So here same, in the chemical kinetics also, slow step is the rate determining step, and in the slow step there is involvement of haloalkane only, not the nucleophile. In slow step there is involvement of haloalkane only and not the nucleophile. That's why the rate of reaction will depend on the concentration of haloalkane, but not on the concentration of nucleophile. Okay, so that is here. Now another point, keep in the mind. Shape here, what's the hibernation of here when carbocation forms, like this carbocation has been formed. So its shape will be trigonal planar. So once the bromine has been gone or any halogen has been dissociated from there, there is formation of carbocation, and the shape of this carbocation became trigonal planar. So then after, the nucleophile may approach toward this carbon, alpha carbon atom, from the direction in which the halogen was present, or from the backward side of which the halogen was present. That means the nucleophile may bond to this alpha carbon atom from the direction in which the halogen was bonded. So in that case, what was the arrangement of this group? That will remain same. Again, that will arrange in such a way which was the arrangement in case of haloalkane. And if the nucleophile will bond to this alpha carbon atom from the backward side in which the halogen was present, then the other groups will inverse. So there will be retention of configuration, there may be retention of configuration or inversion of configuration. So when the reaction was taking place through SN1 mechanism, there was only inversion of configuration, and when the reaction will take place through SN1 mechanism, then there may be retention of configuration as well as retention of configuration. When the reaction will take place through SN1 mechanism, there will be inversion of configuration as well as the retention of configuration. while when the reaction will take place through SN2 mechanism, there will be only inversion of configuration. Okay guys, that is here. Now let's see here. That was about this. Now about the stereochemical aspect, we will discuss once more. Then let's see here. Among these one, the reaction takes place through SN1 mechanism or through SN2 mechanism, but the product will be same. The reaction takes place through SN1 mechanism or through the SN2 mechanism. The product will be same only. Okay. So, if from one hand you give and other hand you take, same amount you will take. Or if you give firstly and then after take, or take firstly and then after give, amount will be same. So the reaction takes place through SN1 mechanism or through the SN2 mechanism. The product will be same. And in the examination, this one here, for the 12th board examination, this chart is not too much important. That is also important and you should not ignore about this one. But in the IIT main examination and in the NEET examination, questions asked from this portion. And there is also chances of asking from these portions in the CUET examination. Okay, so let's see here. First of all, we will discuss about these products, what is forming here. First one is when NaOH is reacting. So when NaOH is reacting with haloalkane. So suppose this is molecule I am taking. This one, you react with aqueous NaOH or KOH. Okay, here aqueous, be careful, here it should be in aqueous KOH or NaOH, whatever be that, whatever you would like. So I am taking here because same process there will be, so that's why I am taking here KOH. So what happened here during this course, aqueous, in aqueous state, the KOH will dissociate into K plus and OH minus, and the NaOH will dissociate into Na plus and OH minus. So the nucleophile here, so the nucleophile here OH will replace the halogens. What happened? The nucleophile OH, here nucleophile is OH minus. So this OH minus will replace the bromine. So OH minus will come here. So Br minus released, that will combine with this potassium. So finally the product will be guys, keep in the mind here, about that we will also discuss. When haloalkane will react with alcoholic KOH. Here aqueous KOH, now that means here the solvent has been taken as water. So in the water you add the haloalkane and add KOH. Then this will be the product. That means alcohol will be the product. But when you will take the alcohol, then what will happen? There will be elimination reaction. The bromine of this one will combine with beta hydrogen and will form HBr, and there will be CH2 double bond CH2 plus HBr. This reaction here, keep in the mind, here not it is, this one is not the part of nucleophilic substitution reaction. This is the example of elimination reaction. About that we will discuss. So it might be a number of students do the mistake in the examination. That's why I have discussed right now here also. So it's a necessity to keep this information in your mind, that when aqueous NaOH or aqueous KOH will be taken, then there will be nucleophilic substitution reaction. While when alcoholic KOH or alcoholic NaOH will be taken, there will be elimination reaction. Okay guys, now let's see, that was the first one. Second one, when you react with water. So haloalkane, this one, that's you react with water. Water is like that. So here water, actually in water there is H plus and OH minus. Nucleophile is OH minus. So of this one, the OH minus ion will replace this bromine. So that become Br minus, and from here the hydrogen will release. So this hydrogen will combine with this bromine and form HBr here, and OH has been replaced here. So that become alcohol. So when you have reacted the haloalkane with aqueous NaOH or KOH, there was formation of alcohol, and when you have reacted the haloalkane with water, then also there will be formation of alcohol. Now third one is when you react with NaOR. So let's see here, this one is done, then after here. Okay, let's see here. So reaction with NaOR. NaOR. So suppose this compound, R means alkyl group. So alkyl group I have taken CH3, O and A. And what's its IUPAC name? Here oxygen is bonded to the methyl, so that will be called methoxy, and sodium is here. So firstly we write the name of a cation, and then after the name of anion. So that's why this compound will be called sodium methoxide. So what happened here? So here the electrophile is methoxide ion. Here is negative charge and sodium has positive charge. So electrophile here, nucleophile is methoxide ion. So this one here, oxygen has the negative charge. So this oxygen will get bonded to this carbon, and bromine will release from there. The bromine released, that will combine with sodium, Na plus, and that will become NaBr here. Now what's the structure? This CH3, CH2. Now this CH2 is bonded to this oxygen, and that oxygen is bonded to methyl part. So that's why here will be oxygen and here is the methyl part. How to write its IUPAC name? It's the ether. One side alkyl, another side alkyl. That means in the two sides of oxygen there is alkyl part, and that will be called ether. How to write the IUPAC name? So IUPAC name here will be the chain which is of a smaller length. The chain of a smaller length, that will be, for that we will write oxide. So that will be called methoxide. And for the longer chain we will write alkane. For a smaller alkyl part we will write alkoxide, and for the larger alkyl part we write alkane. So here is methoxy and ethane. So its name will be now. Let's see about the next reaction. What happened here? NaI will dissociate into Na plus and I minus. I minus is the electrophile, so I minus will replace the bromine. So bromine release from here, that will combine with sodium and will form NaBr. So compound will become recall about this type of reaction. We have discussed earlier also. What is that? When there was a name reaction in halogen exchange. So keep in the mind, watch out if not stacking in your mind. Then watch the video again. So here, that was halogen exchange. The tariff fluorination and iodination was difficult. So what we have done goes there. Now, we are going on. This one completed. Now, reaction with ammonia. Same here. What happened here in ammonia? There is a lone pair of electron. Here, chlorine has negative charge. This carbon has positive charge. So this nitrogen will get attracted toward this carbon. So bond between this carbon and this chlorine will dissociate. So what will happen here? This one becomes CH3, CH2. Here nitrogen will be there and 3 hydrogen here bonded. This nitrogen will donate. Once the chlorine will go from here, it will take its own electron as well as the electron of carbon also. So there is a positive charge on this carbon atom. Nitrogen will donate 1 electron to this carbon atom, and through other electron it will do covalent bond formation. So for this nitrogen there is loss of 1 electron. So there is loss of 1 electron for the nitrogen. That's why 1 positive charge will appear on the nitrogen. Then after, this compound will become unstable. So what to do? This nitrogen will take the shared pair of electron of this NH bond. So it will release H plus ion. This H plus ion released. This H plus ion released will combine with this chlorine. What is happening here? Since there is a positive charge on the nitrogen, that's why nitrogen will attract the NH sigma electron towards itself. So again 2 electrons will come to this nitrogen, one of its own and one of the hydrogen. So the hydrogen will release in the form of H plus, and here is Cl minus. So this H plus will combine with this Cl minus and will form HCl. So here will be, structure will be that is, what is IPAC name? So its IPAC name will be here. For NH2 we write amine. For this group we write amine. And here ethane. Ethane, so that will be A of ethane. That is vowel, E is vowel, and amine, A is also vowel. So 2 vowel we don't write during the IPAC nomenclature. So E will replace by amine. So IPAC name will be ethanamine. This reaction I am doing, and third one you will have to do. I shall not do third one. Listen about this reaction. This compound. What is the IPAC name? Here 2-alkyl group is bonded to the nitrogen. That means 2-alkyl group is bonded to the nitrogen and not to the carbon. So for that we will write N. So one longer chain. For the longer chain we will write amine, and the smaller one will act as substituent. So we will write N-alkyl. So here the smaller one we will consider a smaller and one the larger. So it will call N-ethyl. So IPAC name of this compound is 1-ethyl ethanamine. So where I am reacting chloroethane with an ethyl ethanamine. Same here as we did here. Here is slightly negative charge on this carbon, slightly positive charge. At the nitrogen atom, there is a lone pair of electron. So this nitrogen will attract towards this alpha carbon atom. So then after there will be cleavage of this CCl bond. So compound will be and this nitrogen have donated 1 electron to this carbon, because when chlorine have gone from there, that has taken its own electron as well as the electron of carbon also. So there will be a negative charge on the chlorine halogen, there will be a negative charge, and this nitrogen have donated one electron to this carbon, and through other electron it has done covalent bond formation. So for this nitrogen there will be loss of one electron, it has donated one electron, so there will be development of a positive charge on this nitrogen. Okay, then after what happened, this nitrogen will take the shared pair of electron of this NH bond. So what will happen? This compound, again lone pair of electron will appear on this nitrogen. What happened here? What to write the IPAC name? To one, we will consider the longest carbon chain, and the other two will be the substituent. This substituent is bonded to the nitrogen, so that's why we'll write N diethyl and ethanamine. Okay, now let's see reaction with KCN. Now let's see reaction with KCN. You already know the KCN is the bonding between KCN, there is potassium and Cn minus, will be ionic. So ionic bond, so that will dissociate very fastly. So what happened? Let's see this compound. So here is K plus and Cl minus. So what happened? The carbon can also bond to this carbon, the nitrogen can also bond. But what happened? Bonding between the carbon and carbon, bonding between the same type of atoms, that means bonding between the atoms of same element will be stronger, because in that case there will be no polarity of bonds. So bonding between carbon and carbon will be stronger compared to that of between carbon and nitrogen. That's why the carbon-carbon bond will take place. So here carbon will bond there, so Cn group will bond to this carbon and Br minus will release from there. That Br minus will combine with K plus. So structure will be here. Here carbon and this carbon bond form, because here no less polarity. If there be nitrogen, there will be more polarity. So that's why this carbon has been bonded, and Br minus will combine with this K plus. So that become its IPAC name. How to write? So here total number of carbon is 3. That is the carbon of the functional group. Also we will have to count. We will have to also consider the carbon of the functional group when we will have to write the IPAC name. So here IPAC name. So 1, 2, 3, 3 carbon atom. So we tell propane, and here the functional group name is nitrile. So N is a consonant, not a vowel. So the vowel E of alkane will not replace. So it will be called propane, E will written there, and nitrile. Okay, and KBr. Now reaction with AgCN. Listen, in case of AgCN, bonding is not ionic. Bonding between silver and carbon here is covalent, not ionic. In case of AgCN. So how the reaction will take place? So there is a lone pair of electron at the nitrogen. Now here slightly negative charge, here slightly positive charge. So nitrogen will get attached toward this carbon atom. So then after bond here will dissociate. So compound become, and silver will dissociate from here. That will combine with bromine and that become AgBr. What's the IPAC name of this compound? Here carbon is not bonded to this carbon. The carbon of the functional group cyanide is not bonded to the carbon. So you cannot say 3 carbon atom. 3 carbon atom is not together. Here that is not in the chain. So that's why that is called isocyanide. So its IPAC, its name will be now. Let's another example. Now we react with Ag and O, KNO2 and AgNO2. Now consider about the bond formation. Here K plus and NO2 minus. Of NO2 minus, the extra electron will be with this oxygen. So this oxygen will have high electron cloud density compared to that of this nitrogen and this oxygen. So this oxygen, when you draw the structure here, again I am replacing another one. So NO2 is like this. So this oxygen will get attacked over this carbon. Bond will dissociate from here. So product will be this one. And but when you react with Ag and O2, next reaction. So here bonding is like this. Like this here, AgNO2, bonding will be like that. Okay? Oh, sorry. Not like that. There is covalent bonding here. So in this case, what happened here? So this oxygen is already bonded to this silver. So there is a no pair electron at the nitrogen atom. So this nitrogen will get attracted. IPAC name. What's the name of this compound? It will be simply ethyl nitrite. NO3 is nitrate, NO2 is nitrite. So name of this compound will be ethyl nitrite. And this compound, NO2 will be there and AgBr. In this compound, nitrogen is bonded to the carbon. So that will be called nitroethane. It is the nitrogen derivative of the compound. But ONO, that is not the nitrogen derivative of compound. That is not the nitrogen derivative. Because oxygen is getting bonded there. So that will be for this compound we write nitrite. And for this compound we write nitro. So its name will be nitroethane. Okay, 2-3 reaction more. So let's finish here. So when we react with this silver, so very simple here. So silver acetate here. Suppose this compound here. So same here, that will be here, this oxygen will get bonded and product will be So this oxygen get bonded. So they have oxygen. This oxygen is bonded to this acylic carbon, and this acylic carbon is bonded to this methyl. So like this, plus. How to write the IUPAC name of this compound? This side no acylic carbon, and this side is acylic carbon. So for that we will write alkyl, and for this one alkanoate. So its IUPAC name will be now. Let's see reaction with LiAlH4. LiAlH4 will be called lithium aluminum hydride, and the LiAlH4 is a very strong reducing agent since it's provide the hydrogen. LiAlH4 is a strong reducing agent as it provides nascent hydrogen. So what will happen? Let's see this reaction. So it will provide nascent hydrogen. So hydrogen will replace this bromine. So hydrogen will replace this bromine. So it will again bonded to this. This becomes CS3. Two hydrogen was already, and one hydrogen has been bonded. So CS3 and HBr. What happened here? Ethane formed. Last one. Suppose this compound. So what happened here? That's bromine will combine with this copper. This will get bonded. So again, compound become here butane. So that was the reactions. Usually what happens? There will be in the IIT main or in NEET examination questions given in the form of reactions, and since directly reaction is not there, but that has been here taught in the exam here, this one that has been mentioned inside that, and the students could by applying them could find the reactions also. So a number of students think that in the IIT main or in NEET examination questions don't ask from the NCERT, but students only 5% questions will be outside of the NCERT. And why 5%? I told maybe I will not so much experience that I could find out that 5% is how can we find out from the NCERT. But as I have observed in my 21 years of teaching career, as I have watched that more than 95% questions asked from the NCERT, provided that if you have studied the NCERT book by understanding, not by you have tried to mug up that. Okay, so it's all for this class. In the next class we will discuss further on the elimination reaction shown by haloalkane. It's all for this class. Thank you, Team Educate.